So hello everyone, this is another day of solving Leetcode until I get placed. So currently, as you know, I'm in my third year and I'm grinding my ass off on Leetcode again. तो भाइयों आज और एक क्वेश्चन करेंगे Leetcode. चलो लेट्स सी. UOTD तो हो गया. Let's solve a DFS question. Let's see what we can solve. Lowest common ancestor of a binary tree. Let's see this question. नॉट श्योर भाई कैसे करेंगे, लेकिन DFS आजकल मैं थोड़ा सा शुरू कर दिया हूँ तो मे बी ईजी होगा. गिवन अ बाइनरी ट्री, फाइंड द लोवेस्ट कॉमन एंसेस्टर LCA of two given nodes in the tree. According to a definition of LCA on Wikipedia, lowest common ancestor defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants. Okay, जैसे 5 और 1 दोनों डिसेंडेंट होने चाहिए. 5 और 1 दोनों डिसेंडेंट हैं 3 के. ठीक है. So what I can do is I can find all the ancestors of Q, all the ancestors of P. I get all the common ancestors, right? But how do I find the lowest? 5 और 4. 5 यहाँ पे, 4 यहाँ पे. 5 है इसका आंसर, राइट? Find all the ancestors of P, all the ancestors of Q. I'll have the common ancestors. The problem is I have to find the lowest common ancestor, right? Lowest node. I have to store them with their level. Lowest common. How do I store them with their level? That's the question, right? Let's see if 5 and 4 is 5. First question is, how do I find all the ancestors? I can find all the nodes connected. Ancestors. I can't go backwards, right? I can only go left and right. So if I reach 1, okay, until I reach, okay, makes sense. Is this a BST? No, it is not a BST. Suppose I want to search for 5. I go left, right for 5. Only solution that's coming to my mind right now is I'll have to go till P and till Q, store each element along with its depth, and then in the both list that I'll be forming for P and Q, I'll have to check which is the common with the maximum depth, right? With the maximum depth which is common in both. So that's the solution. That should work. So let's see how to code this. That's another challenge. So till q. Store all elements along with their depths. Find common in both with highest length, right? BFS green star, take a head, int depth, vector int ampersand nodes. P and Q are surely inside, right? So I don't have to worry about that. If also what I'm going to search for, int search, right? What I'm searching for. So if head ka val is equals to search, what I need to do is nodes. Oh, it should be vector of vector int nodes, right? Nodes of nodes dot push back. Head ka val depth or better depth plus one head return, else अगर नहीं मिला, I don't find the element, I just have to traverse more, right? So I just have to traverse head के left. अच्छा I have to traverse only if head का left exist. Traverse head का left depth this one B and search. If head का right exist, have to defer search on head के right left this one search. Okay, so this is the DFS, right? I think this should work. So let's define vector of vector int. This is going to be for pvec. We name it pvec. And vector int qvec. Then I'll just do DFS root depth 0 pvec. Now search for p. DFS root depth 0 qvec, search for q. Right? So what this should do is this should fill up pvec and qvec pvec and qvec, this should fill up these vectors with the nodes that are the ancestors, and I need to search for common nodes in them. I need to search for common nodes, but depth can be different, right? What is the number of nodes are in this range? So do I need to iterate on both of the vectors? Oh, if I sort them, I get the common ones, right? Let's say I sort pvec on the basis of I'll just sort those two vectors on the basis of not the index, on the basis of their values. So if I sort them on the basis of values, I get a how will I get same? First I should just print oh, okay, so I'm given the node. All the node values are unique. Okay. Pika val and qka val, right? Okay. Case one now put 2,5. 2,5. Okay. For p it is 2,5. So first case p is 5. Depth is 2. Ancestor is 5. If this is not, still I have to depth right? Because if it is found, it is fine. If it is not found, yeah. So here it is. If it is found, then I return. This should be it. Y is 1 1 2 0 and 2 8. 1 1. Oh, it is searching on the right side. If it is found, Should I put a bool found? Not found. Not found. Found equals 1. 10%. Bool. We have to do this. Just have to false, right? Found. So what I've done is I've added a boolean found so that it does not go more in depth. Wait a minute, type bool. What does this mean? Can't do this. Why? Bool found of p equals to false. If I do it, found of p. Okay, 2 and 3. Second case again. Battery almost slow. Shit. Okay, so let's see what if I iterate on both. What if I iterate on both? Bool found of q false and found of. Let's try iterating both, okay? For int I equals 0, I less than p vector size I plus plus. For int j equals to 0, j less than q vec dot size j plus plus. So once I went in q vec and then I went in p vec. So if p vec of I of 0 is equals to q vec j of 0. If that's the case, then it is a common node. If it is a common node, what I have to return is I have to return a tree node, right? So instead of storing vector int, I have to store it in a pair of First of value, right? So I have the common node. If I have a common node, min index, so I'll make it min depth, max depth. I'll make the max depth. I need to find the max depth, right? Depth, okay. So I'll put it in min and max depth is equals to max of max depth comma okay, so two nodes will be equal now. Both nodes will be equal. It doesn't have to be the value, it has to be the node. Okay, so I can make a array. I'll update the max depth to this value and max depth node will equals to this node, and simply I'll return max depth node, right? This should work. What's the problem in this one? See out करेंगे. Three and three is the common. 5 and 5 was. How can 5 and 5 be common? It can't be common. 5 and 5 can't be common. While searching for Q, I went. No, so we went left. We didn't find. went left, we didn't find we didn't find 1 because Q was 1. Q was 1. We didn't find 1. We went right. Head of right is 1. Head of val equal to search. If that's it, then we push the head and depth plus 1. We put found equals to 1 and then we return. Q vector is 3562 471 356274 1. Why are these values in this? Okay, the problem is if I'm going to the left, I'm searching for Q. See, I'm searching for Q. No, I'm searching for Q, but I'm going left first. Because Q can be in either side, right? So if I went to the left, I'm adding it to the node, I'm adding. But if I didn't get anything, I don't have to add all those things. That means I have to pop. If I went left, I didn't find anything, I'll have to pop everything, right? 3516208. 3516208, and I think it was a 4 and 7. 4 and 7. Okay. So if I want to search for 1, first I'll have to go to the left. I added 5. I add 3. I add 5. I add 6. I add 7. I add 2. I add 4. Then I add 1. So all these things were added. I have to pop them out, right? I have to pop them out also. Okay. Pop them. So what goes wrong here? Q is 5, P is 4, P is 5, Q is 4. 3 is added, 5 is added. I found P. So P के ancestors क्या क्या हुए? I added 3. I went left. Not found. DFS depth first search किया, ठीक है. Found 5, return हो गया. I went right. Added. Okay, so nodes is just a temporary storage, right? So what I was doing wrong is, even after finding that even after finding the position of the element, I kept on popping it for some reason. So whenever if it is the element is found, I just need to stop the DFS, and my nodes array, the nodes vector will have correct number of pairs. So, but how can I optimize this? Right now it is not very optimal. What can be optimized in this? Maybe the iterations. This is a n square, right? The n into n. Can this be optimized? Wow, too many. How can this be optimized? Is there a way to search for common ancestors in lesser time? I was thinking about sorting. Oh, it can be. It can be done. Use a hash map. Huh. Maybe it can be done. Vector of let's say v of size if I store the common ones. What if I merge both? If I merge both, Now for each level I have this. Now I just have to iterate the MP. I have created a map so that I have now the common nodes. I have common nodes in each level. Right now I have all the nodes of which are in each level. So I need to start iterating from the highest level. Problem is in an unordered map I don't know how to iterate from the highest level. So let's say I iterate from an arbitrary level. How do I find the highest level? Yeah, I can do that. And high level with common nodes. It's not high level with common nodes. I don't think I can optimize this right now. We'll see this later. Thank you. That's it for this video. I hope you understood the solution.